Hi folks, this video is part one of a two-part video series to demonstrate the benefits of SD-WAN on the Fortinet FortiGate platform. I'm going to start by giving you a quick overview of the topology, explain how the FortiGate is configured for SD-WAN, and show you a demonstration of what happens to a streaming video when network congestion is introduced into the environment and SD-WAN is not enabled. Let's get started. The topology for the purpose of this demonstration is relatively straightforward. It is a common scenario where you have a branch office that needs to establish connectivity to a data center where some services are hosted. In this case, the video client behind the branch FortiGate will be streaming video from the video server located behind the data center FortiGate. For LAN connectivity, each FortiGate serves as the default gateway for their corresponding locations. For WAN connectivity, the FortiGates establish connectivity to each other over the simulated ISP-A and ISP-B networks. These networks serve as the underlay network used for transport between the two locations. On top of these networks are established SD-WAN IPsec tunnels to build an overlay that will be combined together to form the SD-WAN zone on the FortiGate. The critical components used for the simulation of network congestion within this lab environment are the transparently connected WAN bridge hosts. They act as a bump in the wire to introduce latency and packet loss, which will be important to observe how streaming video behaves in these conditions. Before we get into the demonstration, let's review the configuration of the branch FortiGate. One point to note, SD-WAN decisions are made at the firewall, not by a centralized controller. Due to this, there is a lot of flexibility on how the FortiGate can be set up to achieve the benefits afforded by SD-WAN. First, looking at the network interfaces, you can see that there is an inside network where the video client resides. We also see two ports configured for connectivity to ISP-A and ISP-B networks. VPNs are built to ride on top of these connections and will serve as the overlay network for SD-WAN. This is confirmed by seeing that the SD-WAN zone is being used by both of these VPN connections. Let's take a deeper look at the SD-WAN configuration. The SD-WAN zone consists of the VPN connections transported over ISP-A and ISP-B. If we expand the virtual WAN link, we see that there is a cost of 10 assigned to VPN ISP-A and a cost of 20 assigned to VPN ISP-B. Take note of this as it will come into play just a little bit later. Next, we have the performance SLA. This is used to tell the FortiGate what measurement to use when making decisions based on SD-WAN. Typically, the SLA is configured to monitor an endpoint that is on the remote network that you want to connect to via SD-WAN. For the purpose of this lab, we chose to monitor the inside interface of the data center FortiGate. You can see by these green arrows that the branch FortiGate has successfully reached the data center FortiGate and the network conditions are optimal. Looking at the SD-WAN rules, we see that only one rule is configured. It is currently disabled for the purpose of testing without SD-WAN. However, let's double click on this rule to see how it is configured. This basic rule is going to match all traffic that is destined for the VPN tunnels, which is dictated by the firewall's routing table. You can see the SD-WAN strategy being used is the lowest cost SLA. This configuration will use the link with the lowest cost assigned to it as long as it is within the tolerance of the performance SLA assigned to this rule. Within this rule, we have defined both of the SD-WAN members as well as selected the SLA we want to use. Remembering the configuration of the SD-WAN zone, this means that VPN ISP-A will be used first, and VPN ISP-B will only be used if VPN ISP-A falls outside of the acceptable threshold. Lastly, let's take a look at the static routes. We confirm that the firewall routes traffic to SD-WAN based on the destination network, which in this case is the network where the video server resides. Now, before I get into this first demonstration, I want to cover a piece of the configuration I omitted. The FortiGate is configured with firewall rules that allow bidirectional flow between the video client and the video server through the SD-WAN interface. Here's a quick look at the firewall rules. Now that's been established, let's continue with the demo. So first, we're going to take a look here at the video client and just establish that there is connectivity between the video client and the video server. To do this, I'm just going to drop a quick ping from the video client to the video server and confirm that ping is working. So you can see it's established, you're getting replies. If we go look at the session table, we see that the session is established, it's going, it's flowing, it's using ICMP. Everything looks great. So now what I'm going to do is kick off a stream from the video server. And do the Super Mario Brothers speed run. It's long enough. That's what I need. We're going to stream it over HTTP. It's going to use port 8080. Disable transcoding. Don't want to add any additional overhead. Okay. Now we'll go back to the client. See if we can kick off the stream ourselves. Going to open the network stream. It's going to HTTP, the IP address of the server, video server, and port 8080. We'll hit play. All right, wonderful. So now we see the stream that's kicking off. We go back and look at the FortiGate. Refresh these sessions here. Okay, now we see the stream is going over port 8080. We'll add the destination interface so we can see exactly what interface it's using for this. So as you can see, it's using VPN ISP-A. So first what we'll do is we'll validate that SD-WAN is turned off. So we'll look at our SD-WAN rules. Okay, we see that it's in currently a disabled status, hence the grayed out. Now we'll go back, look at the video. Now the video isn't going perfect, and the reason why is because this is actually a console that's being shown over VNC, but you can tell it's pretty legible. You can see what Mario's doing. You can read the numbers and see it's very you're able to capture what's going on here, but you'll see an obvious difference once we introduce those unfavorable network conditions. So let's go ahead and proceed with doing that. So what I'm going to do is take that link that currently ISP-A, VPN ISP-A is flowing over, and I'm going to add 400 milliseconds of latency and 3% packet loss. Now that that has been done, let's go check out the video. Okay, immediately you can see that the video becomes a lot more cloudy, gray, pixelated. It's not working. If I go back to the FortiGate and I look at my sessions again, you see that, bring up this destination interface again, you see that the traffic is continuing to use VPN ISP-A. So even though the FortiGate knows that there is, another non-impacted link to the same destination network without SD-WAN enabled. The FortiGate's not going to switch over because, it's still good enough to get that ping across, although the quality of the link is not great. So let's see the alternative with SD-WAN enabled. Now let's see the same scenario, but with SD-WAN involved. So first, what I'm going to do is enable the SD-WAN rule on the FortiGate. Now that that rule has been enabled, I'm going to go back and do the same series of tests that I did previously. First, establishing connectivity from the video client to the video server. It's there. Latency looks great. Now I'm going to the video server and starting the stream. Same parameters over HTTP, port 8080, no transcoding, and it's streaming. Now, go back to the video client and begin the stream. Again, HTTP, IP address of the video server, port 8080, play. Give it a second for the buffering to happen. Great. You can see that the video is playing, no pixelation, very fluid, colorful. You can tell what Mario's doing. Now I'm going to introduce the same exact network congestion that I did in the previous. I'm adding 400 milliseconds of latency. I'm having 3% packet loss, and I have to do this quick because I want you to see how the video looks on the video client. It's introduced. Oh, now getting there. Oh, I might have been too late. Oh, there we go. So great. So you can see that there was a slight period in when I say period, I'm being probably too generous with that. It was just a moment or a blip of where the SD-WAN had to detect what was going on, but now you can see that the picture's back, it's fluid, you can see what's going on with Mario. Again, this is streaming through VNC, so the choppiness is probably can be attributed to that and not necessarily to what's part of this demo. But yeah, it's going. So let's see what we can see from the FortiGate. Now, at the FortiGate, you can see, when we look at the session, that the session is occurring. Oh, for some reason, it's not showing the destination interface, so let's add that back in there. Okay, so our destination is now flowing over VPN ISPB. If we actually go and look at our health checks, this performance SLA, you'll see that the VPN-A is being detected with a 4% packet loss and approximately 400 milliseconds. It's showing red. It's currently not being used. If we look at our SD-WAN rules, you'll see that the check mark is beside VPN ISPB. And last but not least, if we take a look at the logs, which should be an event. Let's see here. So we see that the SD-WAN has kicked in, and it's now removing access via the ISP-A, and it's using ISP-B. So, if we go in and look at the details, you can see that's due to this health check, part of the health check detection. So, as you can see, SD-WAN makes a huge difference to your users. They might give you a call, or they might make you aware of a temporary 1-second blip. But the key here is that you have business continuity, network continuity. Your user's experience shouldn't be impacted just because you might have a network interruption, which is quite common when you're dealing with certain ISPs. So that concludes this video. I hope it was useful. Please leave your comments and let me know your thoughts. Thank you.